Okay, let's take a look at our first example here of hypothesis testing. So this question is going to ask, the average production of peanuts in Virginia is 3,000 pounds per acre. A new plant food has been developed and is tested on 60 individual plots of land. The mean yield with the new plant food is 3,120 pounds per acre, and the population standard deviation is 578 pounds. At alpha equals 0.05, can we conclude that the average population increased with the new plant food? Okay, so what we're looking at with hypothesis testing is, again, we're testing some type of claim. So we see that on average, there's 3,000 pounds per acre of peanuts, but when there's this new plant food that enters in the picture, that number has increased to 3,120. Now, the question that we have is that just due to random chance? Is that just due to sampling error, or is there something special that is happening with this new plant food? So we're going to work through all of the steps of our hypothesis testing. So the very first thing that we always need for our hypothesis testing are hypotheses. So our hypotheses we will have our null hypothesis. So remember, these are always claims about a population parameter. So in this case, we were looking at claims about the mean. So our population parameter for mean is going to be mu. And so we can always use equals with the null hypothesis, and the null hypothesis will say basically what happens if nothing is different. So this is going to be mu is equal to 3,000. So if there is nothing special about the plant food, we would expect the mean to be 3,000. Now the alternative hypothesis is going to be something that is contradictory to our null hypothesis. So in this case, it will be mu, and it's not going to be equals. Well, it'll either be not equals, larger, or less than. In this case, we're testing the claim that we increased. So we had an increase in our plant food, so mu is going to be larger than 3,000. So these are our hypotheses. We always need to start out with those. Now, to help us figure out what type of test are we going to use with hypothesis testing, we're going to write down a few things that we notice. So one of the things that we notice is that we are working with means. So this is a test about means. Now, this is not one about, say, proportions or standard deviations. We're going to get to those later, but it's going to be means. Another thing that we are also working with is we just have a single sample. So we just have one sample. We're not looking at two different types of groups or anything. We'll get to that later on in the class, but right now we're looking at means. There's just a single sample. Another thing that we notice here is that we know what the population standard deviation is. The population standard deviation, so we have a known population standard deviation. Now remember, when we did confidence intervals, we had a difference between if either we knew the population standard deviation or we didn't know the population standard deviation. That same thing will be true with hypothesis testing, is that is going to lead to a very big difference. And then the other claim to just become familiar with, I mentioned it in the video, just briefly, we have a one-tailed test. Now, this doesn't really lead to too much of a difference at this point, but again, it's just terminology that if you take more statistics, that's going to be something that you just want to become familiar with. Okay, so we're going to be having to do a test with means, one sample, and we have a known population standard deviation. So what I have over on the left side of the screen now is this calculator feature. So if you don't have a graphing calculator with you, there's this program that's called WABA-EMU. So you can download that onto either your phone or onto a computer. It works on Windows, I think it works on Macs, and I think it works on Android devices. So if you have questions about how to download this, let me know if you have troubles, but this is a really great way to be able to use a graphing calculator if you don't have one in person. So it works the same way as a regular calculator. So we can go ahead, we can turn it on. And then where we're going to be going is we're going to use the stat button. The stat button is going to be our go-to spot for all of our hypothesis testing. So you'll press stat, and then you're going to press the right arrow we have used this calc option, but we're going to move on to tests. So this very first test that we see here is called the Z-test. When you're looking for means, one sample, known population standard deviation, these three tell us that we are going to use a Z-test. So just like the Z-test, we'll just choose the enter. Now up top, you have two options. You either have data or you're going to have stats. So the data option, notice that you have a few things below. You have this mu sub 0 we'll talk about, our sigma, and a list. List is where we've entered our data in the past, so we don't have data. We instead have already calculated statistics. So we're going to use the stats option, and we're going to enter in our information from this question into the calculator. So our mu sub 0, so to help us understand what we're doing, is our mu sub 0, this is going to be what the null hypothesis is. So this mu sub 0 is the number with the null hypothesis. This is going to be 3,000. Our sigma, that should be familiar, that's our population standard deviation, that is 578. Our x bar should also be familiar, this is our sample mean. And so our sample mean, if we look back at the question, was 3,120. So we have, oh golly. Okay, so we have 3,120, and then the n is our sample size, and so it was tested on 60 plots of land. So when we choose this mu, this last option, this is going to be determined by our alternative hypothesis. So this mu option we have is either going to be not equal to mu sub 0, we're going to have it be less than mu sub 0, and we have it be larger than mu sub 0. So our mu sub 0, this is some number that we've plugged in. So in this case, we're either saying our null hypothesis is not equal to 3,000, it's going to be less than 3,000, or it's going to be greater than 3,000. So if we look at our alternative hypothesis, well, we see that should be the greater than 3,000. So we're going to go over and choose the greater than mu sub 0. Once we do all of this, we do our calculate option. So now the important things that we need to write down. So when you're writing down this for exams or quizzes, we don't need any of this. So this is not necessary. But the null hypotheses are, and then the explanation of what tests we want is also important. Now, pulling things from the calculator is the next thing that we'll also need to write down. So what we have something called the test statistic. So our test statistic in this case is we have z is equal to 1.608. Now z should be familiar. We have z-scores, and we've calculated lots of things with z is equal to. This deals with the same thing, except we're using the central limit theorem for means. So if you did the central limit theorem for means, you would do 3,120 minus 3,000 divided by our standard deviation of 578 divided by the square root of 60, and you would get 1.608. But this is really important to put down as our test statistic. Then we have our next thing is our p-value. Our p-value that we calculated is this number p, which is 0.0539. Now the other two numbers on the calculator, we already know what those are. But this p-value is important. Remember from the previous video, I said the p-value will help us determine if we reject or do not reject the null hypothesis. So in this case, what we have is we have 0.0539. We compare this to our alpha value. So remember, we look at our alpha value and we compare these two numbers. So what this looks like now is we make the claim here that since our p-value, which is equal to 0.0539, is larger than 0.05, which is equal to our alpha, we have to decide, do we reject the null hypothesis or do we not reject the null hypothesis? So remember, super tiny p-values say that I'm very convinced something's going on. That means that I'm going to reject the null hypothesis. So we do not have a super tiny one that's less than alpha. So if the p-value is larger than alpha, we do not reject the null hypothesis. Now, we have this claim, and that's useful, but what does that really mean that we do not reject the null hypothesis? Remember, we're not saying that we accept the null hypothesis, right? We're not saying that I fully believe that the population is 3,000. What we really mean by this, we do not reject the null hypothesis. We do not have sufficient evidence to believe the plant food. So to believe the plant food changed the mean yield of peanuts. So that's what this statement's really saying. This hypothesis test, our conclusion, we do not reject the null hypothesis, but really the important part after that is that we don't have sufficient evidence to believe that the plant food changed the mean yield of peanuts. Obviously, 3,120 is larger than 3,000, but we don't have enough evidence to really say that's not due to random chance. It's really close, obviously. So if you were a scientist running experiments and you got a p-value of 0.0539, you probably want to try doing more of a larger study to see if we can be more convinced by taking more samples. But so these are the necessary steps for hypothesis testing, and I'll go through a couple more examples of what if we have different types of tests, what if we're given different types of information.